You should see my Visual Studio screen, and now you should see our game. Okay, so I'm going to just remind everybody where we were when we left off 2 weeks ago, which is our player can move around, he'll aim at the cursor, and his animations match his walking, which direction he's facing. So that's pretty cool. He still moves backwards exactly as fast as he moves forward, even though the animation is different. And he moves at the same speed going left and right, too. We're going to fix that later when we get into game balance. But right now, I'm just going to leave it because I want to get on with the shooting bit, which is the next bit we're going to be doing. As you might have guessed, the shooting bit is going to be one of the more involved chunks of the logic because it's like the core of the game. Getting a character to move around on the screen is pretty basic. Implementing a combat system is not. And the way that I know this is because I spent a lot of time online looking at tutorials, and they were like, how to make a complete game? And I'd go through it and be like, oh, I want to make a complete game. This is going to be awesome. Wait, why isn't there any combat? Because combat's hard. And so people will leave that out. And they'll just be like, yeah, and then you can just implement a combat system if you want to. Yeah, that's the hard part. So we're gonna get started with the combat. But in order to do that, I need to talk about some concepts in the world. So I'm going to go to my scene view here. And you'll see that I've got my...
The screen doesn't seem to be loading for me.
What?
Sorry, I was trying to look at the stream, but it doesn't seem to be loading. It's like frozen on this one screen.
Oh, okay. Let me stop it and start it again. That's sometimes... let's go stop streaming. Screen 2. Do you see the game now?
No, it's still like this like Visual Studio screen.
Really?
Yeah. Maybe I'll try for my laptop instead of my phone. Hang on a second.
Jack, can you see the game screen?
Yeah, I can see it. I can see it just fine. I can see you've got Unity open and stuff.
Well, that works. Yeah, okay. I see it now on my laptop. This looks a lot better.
Oh, all right. Okay. So, so what I want to do is I want to demonstrate some stuff about physics and how physics works in the game, because the physics engine that's baked into Unity is one of the reasons to use a game engine, because it has a bunch of physics stuff built in for us, and we don't have to create it all from scratch. So, first I'm going to this is just going to be a placeholder game object that I'm going to put in to demonstrate some things. So I'm going to go to game object, 3-object, cube, and it automatically generates in the space. If I click on the X handle of my rotation widget, you'll see that it's floating a little bit above the ground, but I can put it down to have a height of 0 in the transform. If I put it at a height of 0, though, it's actually halfway through the ground because the center is what the height is measuring from. So I'm actually going to make the height 0.5 because it's exactly 1 meter in every dimension. It's one Unity unit, which is 1 meter. What we take to mean 1 meter. It can be anything you want, but... Okay, but that is... so first let me just hit play and watch what happens when I interact with the cube. So if I go to the cube, it stops me from moving, and that's awesome. Now, so it's an obstacle in my way. If I add a component to this, so it comes, when you add the cube, by default, it builds it with a mesh renderer, which is just the thing that tells the engine to draw it every frame. It renders the mesh. And then the box collider is a box shaped thing that allows the user to collide with it, or other physics engine components to collide with it. To show you what I mean by the difference between the mesh renderer and the box collider, I'm going to hit Edit Collider, and I'm going to grab these handles and just start pulling it out away from the box. So if I look from the top, now you can see the collider is bigger than the box. If I hit play, okay, I can't get any closer to the box than the collider. So the collider is separate from the mesh object. So To set everything back to normal, I can come back to my collider and just set the size of everything in the X, Y, and Z dimensions to 1. And set the centers to 0. Yeah. Okay. So somehow I set the X component very high, so when I went to edit the collider, it went off into space. Anyway, so that's a basic object, and if I add a rigid body to it and put some code into my player, the player will be able to move it around. But we don't want the player to move it around. We want it to act as a target for our shooting right now. Currently, it's too small. Because the raycast that's going to go out, we want to go out from the middle of our player, and it might nick the top of the cube, but it might not. So rather than guess, I'm going to make sure that the cube is definitely tall enough by making the Y value 2. Sorry. Make the transform Y value 2. And then I'm going to move the position to 1. So now it's a 2 meter high cube sitting on the ground, and again, it's going to get in my way. Okay, which is all we want it to do right now. It's just there so we can demonstrate how the physics detection works. All right, so we need to create a new script attached to our player. So we're going to go to simple player, and we've already got a movement script, aim orientation, our custom cursor, and our animator handler. We're going to have a new component called shot handler, and we're going to click create and add, and that will add the C# script, which is going to be empty. I'm going to double click it to flip back over to Visual Studio. Okay. So the shot handler is going to determine whether or not I have hit something. So there's a bunch of different ways you can implement shooting in Unity, and there's a bunch of different ways people do it in video games. One way to do it would be to have a pool of bullets that are actual physical objects that have physics attached to them, and we have the bullets travel from the end of the gun into straightforward and drop with gravity as they move over time, just like real bullets do. And that's the kind of physics you would use if you're doing like a realistic sniper shooter. In our case, we just want the bullet to go straight ahead, and we want it to hit whatever's in front of me when the player pulls the trigger, which is a very simple implementation. And we can do that in a couple of different ways. One way is we can use particle systems that will spawn directly from the origin that we want and go straight forward and die when they hit stuff. But that has some complications too. And so we're going to implement the simplest version of this, which is we're going to cast a ray out from the character, and if it hits something, then that's going to count as the player having shot that thing. To that end, let me grab the script here.
Hey Jim, it's
Yeah.
Tony.
Yeah, hey.
Sorry I'm late.
Oh.
Did I miss very much?
No, so let me show you the only thing that I've done actually. Is I put a new cube in the scene. So I went to the scene view, and went to game object, 3D object cube, and I added this cube here that's right in front of my player. I set the position of the Y value at 1 and the scale of it at 2, so it's a 2 meter high cube in the scene. If I press play, then my player runs into it. And we're using that to show how the physics detection works. And
Okay, thanks.
That's literally the only thing we've done. We're just about to start. Sorry, there's one more thing we did. We went to our player and we added a new script called Shot Handler. And we were just opening that up in Visual Studio. We have not written anything to it yet, but we're about to. So if you add Shot Handler.
All right, I'll do that. Thank you.
Okay, so here we go. So what we want to do is we want the game to send out a ray from the player, and if there's something in front of it, when the player presses the fire button, then that counts as a hit. We're going to start with just the ray so that you can see how that works. Then we're going to add in the logic to do it conditionally if the player is pulling the trigger, and then we're going to do a whole bunch of other stuff. Okay, so the first thing we're going to do is let me grab this and copy this. Let me grab this actually. And And let me open up Notepad so I can get this in the right format. Sorry, I should have had this done ahead of time. Okay. And then go back here, and we're going to get over here. Put this here. And these should not be commented. Okay. So, actually, okay. So I'm going to copy a short piece of code into the chat window here. And this code is going to go into our update function. So let's go through, as you're copying and pasting that, what this is doing. This is going to tell the game every frame to cast out a ray from wherever I'm telling it to come from. I have an object here called my ray source, which is in red squiggly because we haven't defined it yet, but we're going to in just a minute. It says go from that transform position of the ray source and go straight forward, and then send out what's called a raycast hit, which is what this is defining. This says create a raycast hit called hit, which is not the greatest naming convention in the world, but and then if your raycast runs into anything, then output it into this raycast variable. And you'll see what that means as we start doing stuff with the raycast variable. And then, so start from me, go forward, output any collisions to this hit so I can inform the player that I hit something. And then go, how far do you want me to go? Well, right now we have it set to mathf.infinity. That means go to the infinity that the game engine can handle, not real infinity, because the game engine can't handle real infinity. But it goes to infinity for what the game engine views as infinity. Okay. And then, if it does hit, in other words, if I do this and something is output into my hit variable, then I want you to draw a ray from where we started to whatever I hit and make it red. And then I want you to log into the console the comment did hit. And then if I don't hit, in other words, if it executes this physics raycast and doesn't hit anything, then I'm going to draw a ray coming out that's going to be white and debug log the expression did not hit. That way we'll be able to see the ray transform colors in the game engine when we look at it in the editor. So then up here at the top, I'm going to create a public game object called my ray source. And for now, we're going to say my ray source equals this dot game object. So that says that my ray source should be whatever thing I'm attached to, whatever this script is attached to. Later, as we start playing with different kinds of weapons, we'll have separate dedicated objects that represent different kinds of weapons, because the raycast will have to work a little bit differently. For example, if we have a shotgun, the way we'll do that is we'll cast out a bunch of rays, but in like an arc. So we want to be able to have different objects defined for each point in that arc, which you'll see much later when we get into customizing weapons. For now, we're just using a basic handgun, so it's just going to go straight ahead from this object. So that's all we have to do there. And so so you should have public game object my array source. My array source is set to this.game object, and then on every update, create a raycast hit called hit. And if the physics hits, then draw a red line and tell me that it hit in the console. And then if it doesn't hit, draw a white line and tell me that it did not hit in the console. Okay, so I'm flipping back to the game, and I'm a little swirly down here as it's compiling the code and checking for any problems. And it thinks everything is fine. I have maximize on play checked right now, clicked, enabled, so that when I press play, you can see it in the full screen. But I don't want to do that because the rays are only going to be shown in the editor. So they're only going to be in the scene view. They won't be in the game view. So I'm going to uncheck maximize on play, and then I'm going to press play. Okay, so my player is aiming off at an angle because he's aimed at my cursor. Even though my cursor is not on the screen, the game window below is still trying to aim at where my cursor is. And you see that it's generating a white line that is about waist high and starts at the center of my character. Notice that it's not lined up with his hands. The reason for that is that we want the ray to actually go to where the cursor is, not where the hands are pointing, and they're a little off-center. If you turn the character so that his hands are exactly lined up with this thing, or offset it so exactly lined up with this thing, then it will throw off where the cursor is placed. So we're just going to have to live with a little imprecision here, that the animation won't quite match up to exactly where we're shooting, but it's going to be close enough that the players won't care, especially at the distance that we're showing in our game. So now, if I take my cursor and just move it to around here, so I'm touching, going to be intersecting the cube, you'll see that my ray turns red, and I start to get the comment did hit. The comment is populating down here. This is displaying the most recent line from your console. You can also open the console window by going to Window, General, Console, or if you're in the editor, hit Control-Shift-C. I usually have it docked up here so that I can look at it if I want to. So you'll see that when I'm off to the side, it's constantly generating over and over the comment did not hit. And if I'm pointing at the thing, it's constantly generating over and over the comment did hit. Because it's doing it once per frame, and we're running at something like 160 frames a second right now. Actually, we can look. We're running at 73 frames per second, which is plenty fast enough. So it's doing that 70 times a second, which is not great. It's eventually going to run out of memory and cause the Unity to crash. It will take an hour or two for that to happen, but I've had that happen. So I'm going to change how it's reporting that information. I'm going to click in my console window, I'm going to click collapse. What that will do is instead of printing out that string every time, it's going to increment a counter every time that it encounters it. So you'll see that my did not hit happened 6,051 times the last time I ran in the game, and my did hit happened 1,451 times. So let's hit play again. And you'll see that my did hit on the very first frame because my character was facing the cube, but I quickly moved my cursor down to the side, and now my did not hit count rate is just going up. And if I turn it back, you'll see my did hit count rate goes up. Sometimes that's the most efficient way to look at errors. Sometimes, though, you want to see them in the order that they occurred, so you would check or uncheck collapse based on what you're trying to do. Okay, so, well, that's great. So, but I don't really want to check to see if the player has, because what we're trying to simulate here is the player shooting at a zombie. I don't want to simulate that. I don't want to check that every turn. I only want to check it on the frame that the player pressed the fire button. So I'm going to go back to my script, and I'm going to say I'm going to put an if statement here. Put an if statement in here that says above the raycast hit, if parentheses input dot get button down parentheses double quotes fire 1 and then I'm going to put a curly brace, and then I'm going to go to the end of my else and put another curly brace, and everything we had before gets indented. What this says is get button down is a built-in function to Unity, and again, this is one of the things about using a game engine. They built all this functionality in for us that says that this statement, an if statement, has to evaluate to be either true or false. So if the thing inside the parentheses is true, then do this thing. Same way we did here. If this physics thing it returns something or is true, then do all this stuff. And if it's not true, then do this other thing. What this says with no else clause is if the player has just hit the fire button, then do all of this stuff. And if not, don't do anything at all. There is no else condition here. Input.getButtonDown. You can also use getButton that checks to see and will return true every frame. And we'll use that when we're doing things like machine guns, because we want the player to hold the trigger down. With the pistol, we want him to press the trigger button every time. So this time, for right now, it's just going to check when the button is on the frame, the button is down. If you mouse over get button down, by the way, you'll see that it's a Boolean. Bool is short for the word Boolean, and a Boolean is just another way of saying it's either a thing is either true or false. So where an integer can be any number value and a string can be any collection of characters, a Boolean data type can only be true or false. And then it says there, it returns true during the frame the user pressed down the virtual button identified by button name. Virtual button. Well, let's go back to, click save, because that's everything we need to do here. And go back to our game engine, and I'll click on scene. And then up here in in edit, project settings, this is where my virtual buttons are defined. There's several things that are defined in here: audio, editor, graphics, blah, 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 blah. But it also defines all of our virtual input buttons. We messed around before with horizontal and vertical to get movement, and now we're messing around with Fire 1. I did not have to create this. This was already created as part of the, by default when you created the project. Also, there's another Fire 1 down here. This is joystick button 0, which is the, where's my Xbox controller? Is the A button on an Xbox controller, if I remember right. It might be the X button. It doesn't matter. It's one of the buttons on a controller. This is also created by default. So what this is doing is saying that if the player presses the left control, what the top one is doing is saying if the player presses the left control key or mouse 0, which is a left mouse click, then it will report that Fire 1 has been pressed. Also, if you're playing with a gamepad and you press the A button, then it will also report that Fire 1 has been pressed. This way I don't have to write separate code to handle a gamepad versus my mouse. So I use this all the time. The same reason that we have horizontal and vertical duplicated is because instead of using the left and right arrow keys or A and D for horizontal, it's actually going to use the X-axis of a specific joystick plugged in, which is left and right on the left analog joystick on a Xbox controller. Anyway, so this is where you define that input. And it's already defined for us, so we don't have to change anything. So now, if I press play, and again, I'm not going to maximize on play, now you'll notice that nothing is happening down here, and if I look at my console, nothing is happening. The reason nothing is happening is because it's not executing that check every frame now. It's only going to execute it when I left-click the mouse button in the game window. So I'm going to come down here, I'm going to click the mouse button, and you'll see it says did not hit. And in the scene view, you can see every time I click it, it generates that white line for me. To help me debug, it generates it for me long enough for me to see it. If it actually did it once per frame, it would not be there long enough for me to understand what it was doing. So I'm moving my mouse, so now I'm targeting, the cube, and I'm hitting it. And when I get off of it, I'm missing, and you'll see that my did hit my did hit counter gets incremented every time I hit it, and my did not hit counter gets incremented every time I miss it. So that's pretty good. That's a pretty good start. We've now got actual gameplay functionality built in that the player can now move around, and when he presses the button, it'll check to see if it hits something. If it does hit something, it goes to one chunk of code, and if it doesn't hit something, it goes to a different chunk of code. We can use that to make him start shooting zombies. But before we do that, we need to show that the player is shooting. So we have to shift now from code to art. And this is the part that I like, so I'm not complaining about this at all. This is great. But we have to kind of change gears of what we're thinking about. Up to now, we've been doing how to make stuff work in the game world when the player gave it input. What we have to do now is we have to give feedback to the player, hey, that worked. So the way we're going to do that is we have to create yet another script, because we want the shot handler script to only handle the shot. We want a weapon handler script to handle our weapon. So I'm going to create a new component called weapon handler. And we're going to click create and add. Before we get started going down the rabbit hole of what all is going to be contained in the weapon handler, let's actually add the weapon to the player. And the way that I'm going to do that, if I go to my soldier, you'll see okay, so he's got all the different bodies and heads and legs and stuff. And we have a couple of them equipped right now, or enabled right now, rather. But it's also got this BIP001. BIP is the bones that were generated for this character that we looked at a little bit last time. And if you go down here to the spine and the right clavicle and the right upper arm and the right forearm and the right hand, you'll see a thing called weapon container. This is a conveniently located thing that the creator of this soldier built in for us, so you don't have to guess where the weapon goes. It is going to go where the weapon container is. So I'm going to so I need to drag the pistol into the game, and then I need to attach it to this weapon container. So where is the pistol? Well, it's actually going to be down here in my soldiers. If I go to Tune Soldiers, go to Assets, Tune Soldiers Armies, Models, before we were in Animation, because we were looking at the animation, and click on Weapons, and you'll see there's a handful of weapons here. The actual Tune Soldiers kit comes with a lot more weapons than this. I stripped a lot of them out of consideration for the publisher, because we don't really need every single weapon that he created for the game, and it's, he put some time and effort into it. So I want to make sure that if people want to take advantage of that, they're going to get a lot for their money if they decide to buy this pack, which you don't have to do, but you can if you want to. Anyway, the weapon we're going to use is a USP pistol, and we're just going to drag it. This is a prefab that has been created. This is just the model by itself, and we're just going to drag it into the game. That is not where I need it to be, but at least now it's in the scene. In other words, it's no longer down in my project folder in the assets. It's now an actual game object up here in my hierarchy, meaning it's actually physically in the scene. Real quick, notice that we have a silenced version, and we have a silenced version that has a laser scope. We're going to get to all of this. We have an assault rifle with a grenade launcher. We've got light machine gun. We've got another light machine gun, heavier machine gun, a Molotov cocktail. We've got shotguns. I've got a tactical shotgun, sniper rifle, heavy sniper rifle, and some submachine guns. And this gives us some options to play around with. We can implement all those weapons as we move forward. But right now, we're just going to use the handgun. So the handgun is physically in the scene right now, and but it's not attached to my character. So if I press play, my character's aiming, the handgun is just sitting there. And if I use my gizmo to move around in space, you can see it's actually sitting on the ground. That's not where I want it to be. I want it to be my player's hand. So in the hierarchy, I'm just going to left click and drag this until weapon container is highlighted. And if I let go, you'll see that the weapon is now a child of the weapon container. And we talked about the parent-child relationship before, from our player to our soldier model to all the pieces that make up the soldier. So this pistol is now a child of my weapon container. If I press play, Well, now the pistol moves around. But it's still not where I want it to be because I left it on the ground and I need to put it actually in the player's hand. So with a lot of models, when you're doing this, you have to spend some time fiddling around to make it fit exactly where it goes. Because the creator built a weapon container, though, we can just set the position to 0, 0, 0, and setting the rotation to 0. And we want to leave the scale at 1.25 because it's scaled correctly to match the player. We don't want to change that. So if I move around in space in my thing, you can see it looks like he's holding that pistol now. And if I press play, now he's pointing the pistol and it's in his hand and it's synced up to our animation and everything's fine because it's attached to the actual bone, the hand bone that is attached to the container that's attached to the hand bone that's attached to the rest of the skeleton. So I don't have to do anything else to have it move around with the player. So we're all set there. Okay, so the next thing we want to do is we want to define what a weapon is. So we're going to go to our weapon handler. We're going to go to our simple player, and we're going to open up our weapon handler script. Okay, so when you think about a weapon, there are certain values you think you would want to include. So let's start thinking of what those values would be. So we're going to have an integer here called my min damage, and we're going to have an integer called my max damage. And that's going to talk about how many hit points the gun is going to, how many hit points of damage the gun is going to cause when you shoot something with it. We want to do public game object, my shot effect, and you're going to see what that is in just a minute. And then public, actually I don't want to call it effect, my shot, how about my gun blast? There, that's clear what that is. And then we're going to do public audio source, my audio source, and public audio clip, my shot clip. Okay, so what we're doing is we're going to create some variables that we can define inside the editor or inside the script. The first integer is the minimum amount of damage that a pistol does when it hits something. The second integer is the maximum damage it does. A gun blast, you're going to see what that is in just a second. The audio source says an audio source is from the thing from which an audio clip is played, and then the audio clip of my shot clip is going to be the actual sound that it's going to play. Let's save this, make sure we save everything, and go back to our game. And if you look at the weapon handler script now, it says the minimum damage is 0, the maximum damage is 0. It doesn't know what the gun blast object is, it doesn't know what the audio source is, and it doesn't know what the audio shot clip is. Because we haven't defined any of those things, but we're getting ready to. Let's set the minimum damage to 5, and the maximum damage to 8. There's no reason for that. I just picked them randomly. We want the pistol to not do as much damage as some of the bigger weapons later on, but I want it to do more than nothing. So I want it to take 2 or 3 hits to kill a zombie. So I piddled around with the numbers for a while and came up with 5 and 8, but you can make them whatever you want. You can have the damage be 500 to 800 and give the zombies thousands of hit points. I don't care. My gun blast. We don't have a game object for my gun blast. And this is going to go to one of the models that's in the My Models folder. In fact, it's the only model in My Models folder, and it's called Gun Blast. This is so I can remember what it was. If I take this object and I drag it out into the scene, you see that it makes this gigantic, weird-looking thing, like a bird's head, kind of. What this is a little model that I cooked up in Blender, and it took me like 10 minutes, not even that, not a very long time, to make this model. And it's going to represent the blast coming out of the end of our gun when we pull the trigger. we are going to, okay, so, but it's way too big and it's not the right color yet. So if you look at my prefabs, no, I don't have one. Okay. We're going to create a prefab out of this thing then. And we're going to go to my materials and we're going to create a new material. Actually, we're going to take a material called Gunblast that's already here. Yeah, okay. So this blue spherical ball says this thing is a material and you can drag it and put it onto objects. On Gunblast, I can take my Gunblast material and I can either drag it into the inspector and it will put it on it, or I can take the Gunblast texture and drag it into the scene and it will put it on the object. So you can assign it in a couple different ways. But I wanted to go through what goes into Gunblast, so let's take a look at it. This is the material itself. So if we wanted to create this from scratch, in fact, let's create it from scratch. Let's say create material new Gunblast. So we're creating it from scratch. Okay, so the shader that we're going to use, we don't want it to use a standard shader. In fact, let's drag it onto our object so we can watch our progress as we go. We don't want to use a standard shader because this is going to make this thing look like a big weird object that I built in Blender and not like the fire of gases escaping as the gun is fired. So instead of using a standard shader, I want to go to Particles and Standard Unlit. Now you notice that there's no the edges of the Gunblast are no longer shaded because it's saying just give it a color. The color I want to use, if I go to the HDR, I want to go to my yellows. I want to make it kind of a golden yellow color, and there. And down at the bottom, you'll see that we've got the red, the green, and the blue. As I'm sure you're aware, colors are made up of a spectrum of light. I'm not sure how much in depth to get with this. And in video games, we represent that as red, green, or blue. And if you mix and match various amounts of red and green and blue, you get different colors. So for example, if I take the red value and take it down to 0 and the green value up to 255, which is the maximum, then I get this brilliant green color, which is not what I want. In fact, I want my red to be very high and I want my green to be a little bit lower because I want it to start hedging toward orange more than to yellow. So I have my red at 255, my green at 200, my blue at 0. My alpha down here is set to 255, and what that means is it is completely opaque. You cannot see through it, which doesn't really sound right for a Gunblast. So I'm going to take the opacity here and I'm going to cut it in half to 122. And then the last thing down here is this high definition range intensity. The high definition range intensity is how you represent glowing objects in the game, other than assigning them a light, which you may sometimes want to do as well. I'm going to take the intensity and set it up to +1. And you see it got a little bit brighter. It's not glowing because we don't have the effect in the world for it to glow. But we're going to get to that. And again, it's still way too big, which we're gonna deal with all that in just a second. The rendering mode right now it's opaque, but we want it to be transparent, so I'm going to change it from opaque to fade. And I'm going to change my color mode to additive. I'll beat it. My opacity down. Yeah, that's what I want. So let's get my opacity down to 50. So we can see, we want to be able to see through it because we want to be able to see the ground underneath because this thing shouldn't really realistically block your line of sight, except for it's going to be this bright thing of color in the middle. And make sure my intensity is set to 1. We may move that intensity up if we need to. Okay, so that's fine. Okay, so let's we've got select our Gunblast in our scene, and let's go to the scaling transform, which is the scale tool, which is the R tool on your keyboard. And I'm going to if you grab any one of the handles, we haven't messed with this tool much, so let's experiment with what this does. If you grab any one of the handles, it will scale in only that direction. So if I grab the red handle, it'll scale in just the X direction. If I grab the blue handle, it'll scale vertically. And if I grab the green handle, it'll scale laterally. I don't want any of that to happen. So make sure your scale is set back to 100, 100, and 100. And I'm going to grab the middle object, left click, and see how all three vertices are highlighted? If I drag now, it will scale the whole object in all three directions, which is what I want. And I'm going to scale it down to about 25, or I can also just come in here manually and do 25, 25, 25. If I switch from the scale tool to the move tool, I can move it up in the world, and I can make it go where the gun is. And I'm going to use my widget up here to move around in space to make sure it looks more or less like what I expect from every angle. That looks fine. And if I go to the vertical, it still looks like it's coming out of the end of the gun. Okay, so I'm happy with that. So, okay, we have this gun blast object, but we don't actually want this object to exist to be turned on right now. In fact, we're going to turn it off. Before we turn it off, though, I want to leave it so I can see it for a second, because what we want to do is we want it to be attached to the player so that it is always at the end of the gun. There's a number of ways you can do this. The simplest way is to make it a child of the pistol. Okay. So now the gun blast is a child of the pistol. I'm going to take the gun blast and uncheck it right now. And come back to my simple player. I'm going to leave this expanded, though, because I'm going to want to refer to it in a second. And in my weapon handler script, I'm going to take this gun blast, and I'm going to drop it into the my gun blast object. When we start developing other weapons, we're going to have to come up with a more elaborate solution for this, because the gun blast needs to be in a different place depending on which weapon is active. So we're going to expand our weapon handler script later on to allow the script to figure out which gun blast to use based on which weapon is active. We don't have that logic in right now, so don't worry about it right this second. But we're eventually going to have an ID for each weapon, and then the script will check the weapon ID, and it will activate the correct gun blast based on whatever weapon you're using. That's the plan in the future. For the audio source and the audio clip, let's leave those absent right now, and we're just going to focus on getting the gun blast to work. Okay, so we're going to okay. We're going to copy this. Okay, so we're going to have to add a new piece of code to our weapon handler, and this is, we're going to open weapon handler script, and right now we don't have any script at all. We've just defined a bunch of variables, but we're going to come down here below void update, and I'm going to paste this code in the chat so that you can copy and paste it. Yeah. And I'm going to paste it into my window as well. Okay. So the shot right now doesn't do anything at all. But we've created this thing called shoot coroutine, which is a private, and then it says I enumerator. The I enumerator bit means that it is a separate piece of code that, rather than updating once per frame, it will, once it's started, it will continue executing in real time in the game until it reaches the end of its own script. So this I enumerator coroutine model is the way that we do things that have to happen over a period of time, and won't be interrupted once they're started. So we use this a lot for displaying things like the gun blast, displaying things like the blood stains on a zombie. Anyway, we're going to use this model over and over. So what it says is this is a private, meaning it can't be accessed outside of the script. It can only be accessed inside the weapon handler. I enumerator means it's the coroutine. The coroutine is called shoot coroutine, and it's got two. This coroutine requires two variables to be added. Those variables are the float wait time and the game object my blast. So I'm using a different name here than my gun blast for a reason. And the reason is that we're going to create a new function called public player shoot. I'm going to say public void player shoot. And we're going to put 2 open and close parentheses at the end of it, and then 2 curly braces. So this function is not going to return anything. It's public, meaning another script can access it, which is going to happen in just a second. It's void, meaning it doesn't have to return a specific value. I can also make it, if I wanted to return a value, I can make it an integer. And it says this function has to give me an integer back as a result, but I don't want to do that. I'm going to make it void. And then the function is actually just called player shoot. When player shoot happens, I want to set my coroutine to run. And the way I do that is I'm going to create a... I'm going to come up here into my variables. I'm going to create a private enumerator my shot coroutine, and I'm going to set my shot coroutine to my shot coroutine. I'm going to define this variable, which is an enumerator, as being equal to the shoot coroutine with sorry, I'm looking at 2 different shoot coroutines trying to get them confused. My gunshot fade and my gun blast. And then the next line, I'm going to start coroutine my shot coroutine. Okay, so what is this doing? This is saying whenever player shoot is called by any script in the game, then I want to start the shot coroutine with a float variable called my gunshot fade, which is not defined, which is why it's squiggly, and my gun blast. And then I want you to do whatever is in shoot coroutine with those 2 values. Let's create my gunshot fade up here as a public float. My gunshot fade. And let's set it equal in the script to 0.0.1 f. F means it's a floating point number, and that tells the computer where to stop looking for the float, for the end of the number. We talked about that way back at the beginning. So right now, what this says is go to the shoot coroutine and pass the following values: 0.1 f, or 0.1, and whatever game object I've defined as my gun blast. And then, what does the shoot coroutine actually do? All that it does right now is that it sets the it's going to post a debug value that says I'm in the shot coroutine, just so we know that it's happening. It's going to set the gun blast to be active, and then it's going to wait for however long you tell it to wait, which is my gunshot fade, and then it will set the object to its active flag to false, meaning it's going to turn it back off in the game. So we'll see how this works. Let's put a save and come back into our game. And you'll see now that my gunshot fade, because I defined it in the script as 0.1, it automatically populated this for me. I can still change it though. Whatever I change it to in the inspector will override what is in the script. Typically, I define things in the inspectors rather than in the scripts, so that there's no confusion about which one takes precedent. But it's always the one in the inspector, just so you're aware. So I'm going to leave my gunshot fade as 0.1 right now, and I'm going to click maximize on play. And I'm going to click play. And nothing's happening. The reason nothing is happening is because there is no script calling player shoot. But we have a script that is controlling our shot controls, and that's our shot handler. So we're going to open up shot handler. And at the top of shot handler, we're going to put public weapon handler, my weapon handler. Weapon handler. And what this says is, I'm going to give you a specific weapon handler, and I want you to go to that weapon handler, and we're going to do stuff within it. That specific weapon handler is going to be defined as soon as we start the game as GameObjects.getComponent weapon handler. So that says go get the weapon handler script that's attached to the main game object. Okay. Now the weapon handler is defined, and I know which one it is. It's the one that's attached to this game object. Now, if the player presses the fire button, before it does anything else, I'm going to say my weapon handler dot player shoot. And it will execute the script, the player shoot command inside weapon handler. So this is going to come over here, execute this command, and that command will call the coroutine, and that will start the thing so that my blast will appear and disappear. Now, if we have this all rigged up correctly, and we press play, I should never start sentences that way. Press play. Okay.
Could you please go back to the shot handler? I think I messed up the line of code on the my weapon handler equals.
Okay, so
It's giving me an error.
in the shot handler.
Yeah. Game object. Okay. There it is.
Okay.
Object.get component. I'm reading through just to make sure I spelled it all.
Yeah, it's got to be spelled and capitalized correctly.
Yeah, I got the capitalization, and then at the bottom you put my weapon handler equals player dot shoot in the if. Okay, thank you.
It's not equals. It's just my weapon handler dot player shoot.
Oh, okay. Sorry. Sometimes those look like commas for me.
Oh,
And
it's my weapon handler dot player shoot, and then it ends with a semicolon. Okay, you good?
yep. Yeah, I'm good. Thank you.
Okay, so let's go back to the game and press play and bang, 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 bang. Okay, cool. So we can now make stuff happen when we shoot. It isn't very satisfying though because nothing is hitting in the world. Like I can shoot the box all I want, and I get a comment in my console saying I hit it, but I have no indication that I hit it.
Real quick, I'm
Yes.
getting that fallback editor window error. How do I fix that again?
Oh, if you click layout and change it to anything other than what you currently have it at. So you can click revert factory settings, or you can just change it to 4 split and then put it back to 2x3. So I'll do that so you can see what it does. And go back 2x3, and then I take my project window and I drag it down here, and then I shrink this. And I've done that. These?
Sorry, go ahead.
No, go ahead.
I'm now getting an error that says argument exception input button fire 1 is not set up, even though I set it up. I'm getting input problems.
Yeah. Okay, so can you share your screen? Let me stop mine for a second.
Yeah. Share screen.
Where's my... So I'm going to stop sharing mine.
Let me know when you're good.
I don't currently see it. Are you sharing it?
Yeah, I am. I'm
Oh,
streaming.
I see. Okay, hang on. Okay, so let's go to the file input. Sorry, not file. Edit preferences.
Preferences, input.
Sorry, not preferences. Project settings. Sorry, they moved that. They moved where that was in a recent update.
Project settings,
Yeah,
input.
And then scroll down.
Here, fire 1.
Okay, so go back to your script.
Okay, hold on. I have to change the stream.
It's your.
Yeah, it's being kind of weird.
It's okay.
Hold
I
on,
see what the
I'll
problem is.
change it to just screen.
You have capitalized fire 1 in your script, and it should just be capital F and lowercase IRE.
Oh, there it is. Yeah, my caps lock fire.
Yep. That should work.
All right.
Okay.
There we go.
Cool. So I'm going to go back to sharing my screen.
Thank you.
Yep. And I want to share this one. And go live. Okay, so you guys should be able to see my screen again. I want to minimize it though because it's taking too much of my view. What the chopsticks? Okay. All right. So, right. Okay. So what we don't have is an indication that we've hit anything, and what we want to do is we want to create a thing that happens where we hit a thing. So that means we have to do some programming. We also have to do some art with particle effects. So let's do the simpler bit first, which is going to be, let's create the particle effect for the bleeding when we hit the game object. So if you go to my effects, you'll see there's nothing there at all because I created the folders. Really? No? Yeah. There should be an effect called blood impact. Let's go to, let me center on my player here in the scene view. Let's take this effect blood impact and drag it into the scene. And I'm going to drag it up in the world. And I'm going to, if you click on it, you'll see that it's got a thing underneath it, a child underneath it called blood spurt. And that has a child underneath it called blood spurt 1. So blood spurt 1 is this. I created all of this. So if I click restart, then you'll see the blood spurt happens, and above it we've got another particle effect that runs both of them at the same time. And all this is doing is it's generating a bunch of particles in space and then causing them to fade out over a specific period of time. So every time that I hit a zombie, I want this to happen. So that I'll see that I hit the zombie. But how did I do that? Well, we're going to replicate this whole thing from scratch. So let's start with a new game object. So we're going to do game object, create empty. And we're going to call this effect new blood spurt. Okay. Now you can't just copy all the settings from the existing blood spurt, which I'm going to largely do. But the first thing we want to do is notice that there's there's the game object that contains the blood spurt, and then there's the actual blood spurt itself. And notice that they are oriented differently. They're oriented differently so that I can get the blood to spray out the way that I want it to, because normally I'm going to be shooting the zombies in the body, so I want the spurt to go out like it's going out of their body and onto the ground. So click restart again so you can see that effect. It's gross. Okay. So to do that, I'm going to add a new child to this called create effects particle system. Now, by default, it does not look gory and scary and gross. It looks like a wizard's wand, I guess. And it's sending out little puffballs. The reason it's doing all this is because this is the default particle system that is created whenever you create a new particle system. And it's just saying, I'm going to start at new blood spurt, which is this object that's located right here, and I'm going to spew out these white dots and they'll live for 5 seconds. Unfortunately, the new blood spurt effect I accidentally created inside my player. I can just move it off to the side so we're not inside the player anymore. And I'm going to move it up in the world so we're not on the ground and losing half of our effect. Okay, so if I click on the particle system, I can cause it to stop, and I can cause it to restart. I can stop it, and I press play. The difference between stop and restart is when it restarts, it starts over as if it has not been playing at all. If you hit play after you've hit stop, it will play from where it left off, more or less. Okay, so the first thing, I'm just going to click restart. I'm going to leave it running so you can see the changes as we change things. The first thing is the renderer is using a default particle system. So it's using a material that is the default particle system. And we don't want it to use default particle system. We want it to use our blood material. I have created the blood material here. And if you go to the project and type in blood, you'll see a thing called blood spatter is an image that I imported. And if you expand this, you can see it's a little difficult to see because it's all in white. The reason it's all in white is so that we can make the blood have different colors over time. But it's just an image that I found. I went online and typed in blood splatter, and this is what I found. And then I have a blood spatter material. This material is using a particles material. It's fading so that I can make it transparent, and it's using the color mode of multiply. We won't worry about what color mode is right now. Just leave it at multiply. And we're not going to create this material from scratch, although we can. It's the same way we just did for the gun blast. We'd create a new material, use the shader of particles standard unlit, change the rendering mode to fade, and then we would change the albedo here, rather than changing the HDR, which we changed before, we would change the albedo to the blood splatter graphic. Okay. So this blood splatter material is what I want to use instead of the default material. So I'm going to click go back to the particle system, come down to the renderer, and where it says material default particle system, I'm going to drag my blood splatter up into that instead. And now it's splattering blood. Look how gory. Except that it's not. It's still sending off in a kind of random pattern, and that's not what I want it to do. So we have to change several things about this. And the first thing we're going to do is we're going to change the color, but we actually want the color to change over time. So I think that's right. Yep. So I'm looking back at my original example, and you'll see my color over time has been, my color over time, it starts at a black and it goes up to a red, and then it becomes transparent. And the transparency is shown by these gray and white text boxes in the background, gray and white boxes in the background. That's demonstrating that it's transparent. So if I click on gradient, I can double click on it. This is the one that I built before. And you'll see that it gives me this weird gradient editor. We're going to do this exact thing duplicated down below. So I'm going to come to the particle system. I'm going to go to color over lifetime. I'm going to check it. Every particle can have any of these attributes enabled. But if you don't check it, it won't use it. So I'm checking color over lifetime because I want it to change color while the object is alive. And I'm going to double click on this thing, and it brings up a gradient editor. The gradient editor currently is set to be solid white from beginning to end, which is not very interesting. The top of the gradient editor controls the alpha, or the transparency. The bottom of the gradient editor controls the color. So I have selected the bottom arrow on the far left, and I'm going to click to make it black. Black. Okay. I'm going to click the color editor. So now I've selected the arrow on the far right, and I'm going to make it red. So what happens is over the course of the lifetime, my particles are starting off black and turning red. It's hard to see in the game view preview because they're going out so far because they live a long time. We'll deal with that in a second. The top, I want my particles to start out completely opaque, so I want my alpha to be 255, but eventually I want them to become completely transparent because I want them to fade out over time. So I'm going to grab the top arrow on the far right and change the alpha from 255 to 0. And that says become transparent as you move along this process. And then I want to have one more node in here. The problem is it's going from black to red, and it's going over the course of the lifetime, but it's going to from opaque to fade too. So it never really gets to that brilliant red, as you can see if I zoom out, because it's already transparent by the time it gets to the red value. So it starts off as black, and then it becomes slightly more red, but then it fades out. To stop that, what we're going to do is we're going to left click here in the middle, change this location to 50, so exactly halfway, and we're going to change the color to our bright red. And that way it gets to the bright red and then it fades out. Okay? So that's one of the things we've gotten taken care of. So now at least it's generating the right colors. The next thing we want to do is we want to change the duration. We don't want the thing to last 5 seconds, which is what's lasting right now. We want it to last 0.3 seconds because we want the blood spurt to happen pretty quickly. So now we're going to change the duration of this particle system to 0.3. That doesn't really change anything from what we're seeing right now, but you'll see the change as we move along. The lifetime, so the particle system's lifetime and the lifetime of the particles are separate. We also want to change the lifetime of the particles. So right now, the lifetime, we want to set the start lifetime to 2. So they are now fading out much faster because they only live for 2 seconds. But the color range is still going from black to our bright red in those 2 seconds. Okay. Our start size we're going to set as 1, which is already set. And our start rotation here, we're going to set to random between 2 constants. So you can set the start rotation to be a single value, a constant. You can set it to a curve. You can set it to be random between 2 constants or random between 2 curves. Because of the way we're implementing this, I'm going to make it just random between 2 constants of -120 and +120. The effect you can see here, as I zoom in, is before the particles were all going, starting out oriented the same exact way. Now they're oriented in kind of a random way between these 2 values, -120 and +120. Okay, then we're going to add a gravity multiplier, and we're going to set the gravity multiplier to 1. And now notice that the blood is falling onto the ground because gravity's impacting it. If you want it to make it fly up into space, you can set it to -1. And that will use the opposite of gravity. And if you want gravity to be more intense, you can set this value to even higher, so it will fall faster. But I'm going to set it to 1. Okay. Simulation space, I'm going to change that to local. If it's not already, it is. So I'm not going to change that. I'm looking for things that are different. Looping, we don't want this to loop. When the zombie gets shot, we want this to execute exactly 1 time, like that. But I'm going to leave it as looping for now, just so I can see the effect as I'm editing it. Okay. We are going to... I think all that's the same.
So I missed somewhere where you made the blood splatter the particle.
Oh, okay. So go down to the... In the particle system, go down to the renderer. It may be collapsed, so you can expand it. And I'm going to grab the... I just typed in blood into my project, and I found the blood spatter material. It's got this spherical icon next to it. And I dragged that into my material.
That. I couldn't remember where you click down on renderer. So that's it.
Okay. So, so we need to fix a couple of other things. So we've updated everything in the default settings to match exactly our new particle. The only difference being that looping is not checked, and we will uncheck it at the end. Now we want to look at the next thing, which is emission, which is how fast would you want me to spit these things out? And in our original thing, we say the rate over time is 50. And so we'll do the same thing. We'll set our rate over time to 50. Whoop, that's 560. That's too many bloods. There, that's 50. Okay, but it's still not coming out. So this is my original one. And the effect we're doing is the center bit that's spraying out. We're going to get to the ring is this other effect that we're going to deal with in just a second. So so the emission is doing. So this is my effect. The emission is now doing 50 at a time, but it's not in that tight grouping that it is in the original effect, and that's because we need to change the shape. So the shape should be a cone, which it is by default, and that's drawing you the cone so you can see how big it is. But notice that my radius of my cone in my actual original effect is 0.2, and the radius of my cone here is 1. So I'm going to change the radius to 0.2. And now we've got a much tighter spread of blood and guts, which is cool. I'm going to set the angle to 0. And that makes it even tighter. The angle that it's talking about there is the angle of is not the angle with respect to the world, it's the angle of the sides of your cone. You can spread it out and you'll see the angle changes. But I'm going to make it 0, so it makes a nice tight spray of blood. Okay. And then we don't need to change anything else in this, I don't think. The rotations change, but because of the way we're orienting it, we don't need to do that. So we're going to leave that. And then we've already done the color over lifetime. We also want to do, come down to the particle system and check size over lifetime. And let's expand that. And what it's doing right now is it's going from a very small particle to a very large particle, so it's growing over time. That's not quite the way we want the blood to work. We actually want the blood to go... If I click on the curve, you can see in my original curve, we want to start small and then get big and kind of stay big and maybe shrink a little bit as it moves on. So I'm going to click on my curve, and there are some built-in handlers here. This window, so when I clicked on this curve, this window is populated. Go back to my original one, and let's compare some things that are different. The X value here goes to 3 in my original, but in my default one, it only goes to 1. I'm going to change this to 3. And what that says is, I want you to grow in size until you're 3 times as big as you would be if you were sized at 1. In my original, it goes up to this middle key, and then it stays pretty close to 3. So it gets big pretty quickly. In fact, I can click on this key, which is a little diamond here, and click Edit Key. And we can see when this happens, the time, and it's at 0.424998, and what value it's going to. It's going to like 90.927, about 93%. We're not going to be that precise in making our copy. But I want to add this new key here, somewhere in the middle, close to 0.5. The way I'm going to do that is I'm going to right-click and click Add Key. A key in these curves is a thing you can use to drag around to change the shape of the curve. And you can see in the window, as I make it get large earlier, it gets much more gory. And if I make it get large over time, the particles don't get very big until I move through my process. I want it to be somewhere around 0.4 or so when it gets to its maximum size. If I go back to my original one, you'll see that the curve is kind of flattened here, but mine is dipping down and is doing a thing. The reason for that is because I can click on a key and I can rotate its handles. And since I want the curve to be a little bit flatter, I'm actually going to click on the last key, drag it down a little bit, and drag its left handle up to flatten it. And you don't have to be precise about this. You can play around with these all you want to make them whatever size you want and however big you want. If I move the effect up in space until we get to the end of the effect, because gravity's working pretty well is what's happening, you'll see that the particles over time will turn red and they'll fade out and they'll get really small. Sorry, not really small. They'll stay relatively large is what I meant to say. They're becoming transparent. Okay. So that's pretty great. And let's see, and that should be it. Renderer, I think their start lifetime. Let me restart this. I want to see. I think I'm missing a timing somewhere because, nope. It's not quite matching up, but it's pretty close. In fact, if I hit, that's what the problem is. Let me undo looping. Let's hit restart. There we go. So now it's getting what we want for our effect. Pull it back down to the ground. I'm going to click on the player again just so I can zoom back in, and then click on my new spurt object, and I'm going to click on the particle system and click restart. And now it sprays blood out. And I'm going to pull it up to about gut height, which is where the gun is going to shoot. And you'll see it sprays out, splatters on the ground. Looks great. Now you can do all kinds of stuff with particle systems. We could make the particles bounce off of the ground and that can be an effect that you might want to use sometimes. So let's go to collision. If we check collision and change this to world, now when it hits the ground, you'll see that the blood actually bounces. That's not really what we want for this effect, but you can do all kinds of things with particles, and it's got a ton of built-in functionality. We're going to do more stuff with particles when we start adding some more effects for the gun. And then we want to do one more here, which is the ring of blood around it. So click restart. This is the blood spraying out radially in that circle to give a good effect of what that looks like. It's like, there you go. So you can see it's going out in just a circle around the wound, and that's so that the player gets a good indication of where they hit and what the general area was, in addition to the blood spurting out. Okay, so I'm going to call this one blood spurt fountain. There we go. And then we're going to create a new particle system. Effects, particle system, blood spurt ring. Okay. So blood spurt ring. The duration we want to be 0.1. And again, I'm looking back at my previous example. For the renderer, again, I don't want it to be those puffballs. I want it to be the blood spatter material again. Let's go to... We want the start size, the start lifetime to be 0.5 and the start speed to be 1. 0.5 and 1. And again, I'm just looking at the original one that I built. You can copy and paste it exactly, or you can just use the one that's already there. I just want to demonstrate how you do these things. Again, we'll make the rotation -120 between random between two constants. And in fact, let's zoom in on this so we can see it very well. So right now, you'll see that they're all facing the exact same way. Also, they're billboards, which I will get to in a minute. So we want them to have a random start rotation between -120 and 120, and you'll see now that they're starting in different rotations when they start their life. The emission rate I want to be. Sorry, let me see if there's anything else I need to change up here. Local scale, rigid body. Yeah. Okay. The emission rate is 500 instead of 10. So that's generating a lot of stuff. The shape is going to be a circle instead of a cone. So we're going to say circle. And the radius is going to be whatever it was up here, 0.3. And we'll set the radius thickness to 0. And we want to change the color over lifetime and size over lifetime. The color over lifetime is going to be exactly the same. It's going to be that black to red thing. So I'm going to come back here, color over lifetime, double click on this to expand it, open the color editor, the gradient editor, left click on this button, left click here, drag it to black. Change this to red. Change the upper right hand handle to 0, so it's going to fade out over time. And then right click here, change this to 50, and make this bright blood red. And again, you can fiddle with it, make it whatever you want.
That looks so cool.
You can spend a lot of time playing with. The reason I'm not doing this on the fly, and I'm using an example, is you can fiddle with a particle effect for a week or a month. I mean, they're really neat. Anyway, so the size over lifetime. I'm going to look at my example. You'll see that the size over lifetime is set to a curve again. And that curve looks very similar, except for it's only going to go to a size of 1. So it's going to start out small, go to a size of 1, and then flatten out again. So I'm going to click on the curve. I'm going to right-click to add a key. Drag that key up close to the top. And I'm not going to change the size now to 3. I'm going to leave it at 1. Take this and rotate it down and pull this down. So I'm just trying to make it look sort of flattish near the top. And okay, 0.3, 360 random. Yeah. Then X negative 90. Okay. Okay. Let's see what else we got. And then the renderer. We were not going to change anything in there. Except we are going to change something in there, because if you look at the renderer for the blood splatter here, no, just regular. Okay, well, we'll just leave it as that then. I'm still generating way more. Because I'm looping. Okay, so now it's playing both effects because I'm resimulating the child, and it's not exactly the same. And I can piddle with it to make it look more the same, but that's fine. That will indicate to me that I have hit a zombie. That's clear enough to me that zombie blood has been spilled. Okay, so we have this effect, and we're going to take this effect and we're going to drag it into the My Effects folder. Effect New Blood Spurt, My Effects. Okay, and we want that effect to occur wherever the zombie has been hit. So we're going to have to tell the game to spawn the blood effect when the thing gets hit. And we're going to do it right now in a dumb way, and then going forward, we're going to clean it up and do it in a better way. I just want you to see it work in action right now. So the way we're going to do it is we're going to open up. We're going to open up our player, and we're going to go down to the shot handler, and I'm going to go back and look at my original script. Dang it. Okay. I'm going to have to rewrite part of this, so we won't be able to see the cube bleed until next week. Yeah, it's going to be... I have to rewrite part of that. Okay, that's fine. I'll rewrite it, and we'll have that ready on deck for next week. So, anyway, we covered how to detect if the player has actually shot a thing. Oh, you know what we can do is we can kill the cube. Before we go, let me do one more thing. Let's create a script here called health. We may later want to differentiate between zombie health and player health. But right now I'm just going to have a script called health. And it is going to have some integers. I'm going to make a public integer my max health. Public integer my current health. And public bool is dead. Okay. If my current health is less than or equal to 0, is dead is true. To start with, my is dead is false. Also, if I'm dead, I'm going to set GameObject.setActive false. If I'm dead, I want to be inactivated. Okay, so there I've got a health, and it's got a maximum health and a current health. When the shot comes in, I want to take off some amount of health. To do that, I'm going to create a public void take damage int my damage, creating a new function called take damage that is going to adjust the damage that the object is taking by reducing my current health will be reduced by minus equals, which is the same as my current health equals my current health minus whatever. My current health minus equals my damage. So this way the health component on the cube doesn't have to know what weapon you're using. Whenever you tell it to take damage, it will just subtract however much damage you pass into it using this take damage function, which is how we're going to get this to work. So we're going to go back to our shot handler. Remember, our shot handler says, did I hit? If you did hit, then we want to do something. And the thing we want to do is do hit dot game object. No, how do I do this? No, it should be hit dot game object. Hit dot game. One second.
Is it hit.collider.gameObject?
Is that one of my choices? Yes, it's right, exactly. Because it's a physics object, so it's got to have a collider on it. Thank you. Game object dot get component health. And remember, the get component has this weird syntax of the angle braces, the name of the thing you're getting, and then left and right parentheses. Dot take damage. And we want it to take damage somewhere between my minimum range and my maximum range. So, above the hit collider, we're going to set the damage equal to, we're going to create an int called my damage, and that's going to be equal to random.range. And you'll see that it says float there, but I'm going to use my min. Oh, because minimum damage is in my weapon handler. My weapon handler dot my min damage and my weapon handler dot my max damage. And if I remember right, yeah, we're actually going to make this greater by 1. So I'm going to put parentheses around my max damage and add 1 to it. The reason I'm adding 1 to it is because the random.range will get a number between the minimum value and the maximum value. For the minimum value, it is inclusive. For the maximum value, for integers, it is exclusive, meaning it will never return the maximum value. So it will give me a random number between 5. If my minimum is 5 and my maximum is 8, it'll give me a random number between 5 and 7. But I want it to use one larger value so that it can actually give me a random number between 5 and 8, which is what I'm trying to actually do. Okay. And so that will generate my damage, and then take damage requires, the error it's saying here is, you haven't told me what integer to use, and we're going to use my damage. Okay, so what this will do then is, if I hit something after pulling the fire, if my player presses fire, I'm going to cast a ray. If that ray hits something, then I'm going to check to see if that thing has a health object, and if it does, it's going to cause it to take damage. Actually, what this is going to do is say, go get the health object and cause it to take damage. We haven't put the logic in to say if it has a health collider attached to it, or a health script attached to it. because the only thing I can hit in this script or in this scene right now is the cube. I'm not too worried about that. But we're going to eventually want to deal with the fact that you can hit like a building and it's not going to have a health component. We're going to have some other thing happen. So I'm going to save all this. And because it's gotten to be kind of long, I'm going to go ahead and copy this into the chat so you can compare it if you have any questions. So that's everything we've got for our shot handler logic. Okay, so that's now in there. Everything's saved. Come back to my game. See everything's... why is my game not compiling? Did I not save it? Did I already flip back to the game? Okay. So I'm leaving maximize on play unchecked. I'm going to press play without changing anything. And what's going to happen is that my cube disappears and is dead is checked. The reason is because its current health is 0. I didn't give it any health to start off with. I'm going to give it its maximum health as 10 and its current health as 10. And I'm going to press play. And the cube is there and nothing is happening. The effects are spawning because they're enabled in the game, not because I'm shooting anything. Let me just disable those so it'll stop distracting us. Okay, so now the cube is there and I can shoot it if I want to. And to demonstrate that, I'm going to come over here and I'm going to shoot it. And if I come back to the cube, you'll see that my current health is 2 because my player caused 8 points of damage. And if I come back into the game and I click it again, my current health is -4, the cube is dead, and it's removed from the game. Obviously, we don't want to remove the zombies from the game immediately. We're going to have them fall down dead, make a lot of groaning noises, and be covered in blood. And it's going to be disgusting and gross and awesome. But that's just to demonstrate the functionality that now we can assign health to an object, shoot it, and kill that object. The player still can't be killed because we haven't given the zombies an attack yet. We haven't even put a zombie in the game yet. But that's a pretty good basis for a combat system. So I'm going to stop there, and when we come back next time, I will go through how to spawn the hit effect, the blood splatter, where the object has been hit. And we're going to look at some things that you can do around randomizing that, because if the player hits the zombie in the exact same place every time, it gets a little boring. So we're gonna mess with it a little bit. Anyway, does anybody have any questions? It's about 94 minutes, so I'm going to stop there.
I'm having a take damage error where it says public void. It says public void, take damage, and it's an error. And the error is must declare a body because it's not marked abstract, extern, or partial.
Right. So that's in the health script.
Yeah, it's in health.
Public void, take damage. Let me go. Let me share your screen.
Oh, I see. Oh. Hold on. No, I just don't have that last bit of code. So then it's.
In fact, let me put the health. I'll put the health in the chat as well. And I need to take another backup of the project and send it out. Just make sure everybody's starting at the same spot. Oh, did you have a friend that was going to be joining? Let me stop recording.
Yeah, I did. He was wondering about it.
Let me stop the.